Right, guys, so I have attached with this post as well just the answers to the A, B, C, D, and E parts of the question 1 and question 2 work from the last day. I specifically asked you not to do the mathematical parts of these questions because I wanted to kind of do a little video around how to do them. So the plan here today is I'm going to show you how to do the mathematical part, or the mathematical calculation for the first question. And your work tonight then will be to do the mathematical part for question 2, okay? Using this as an example. So the key thing here is the whole purpose of us doing the titration in the first instance is to try and get the concentration of one of the substances. So if you look here, we have the concentration of the sodium carbonate. It's 0.05 moles. And here then in your question, part F, you're asked for the concentration of the hydrochloric acid. So basically you're comparing and contrasting the two solutions based on the concentrations of each, the volumes of each, and the way in which they react in the reaction itself, okay? So when we look at this, we have two things to look at. So we have an acid and we have a base here. So we'll do acid in red, a bit like junior cycle acid and bases, and we'll do our base in blue. Now, a couple of things we need to find. We need to find the volume of the base. We need to find the molarity, which is the strength. So the volume of the base, the molarity, molarity of the base, and the number of moles of the base that are used. So there are the three things we need to find for that. And exact same for our acid, the volume of the acid, the molarity of the acid, and the number of moles of the acid used. Okay? Now, we will get this information from the question. Okay, so if we look here, the volume of the acid, do we know? So let's say the student used 0.05 moles of solution of sodium carbonate. Primary standard, find the concentration of the hydrochloric acid solution. A pipette was used to measure 25 centimeters cube portions of the Na2CO3 from the HCl. Okay, so it doesn't tell us anything about the volume of acid there. We have a volume, but that's the volume of the sodium carbonate, which we actually will write down, right? So we have the volume of the sodium carbonate here. Okay, so it's 25 centimeters cubed. Okay, remember, Na2CO3 is our base and HCl is our acid. So with that done, then student carried out a number of titrations and noted that on average 22.6 centimeters cubed of hydrochloric acid solution. There's your volume of your acid. So 22.6 centimeters cubed. Okay, so that's that bit done. And then reaction 25 centimeters cubed, we had 25 done already. Of the 0.05 molar Na2CO3. That is the strength of the base, 0.05 moles. That's how strong it is. And we're asked for the concentration of the hydrochloric acid, so that is going to be X. So we have two volumes for each filled in, and we have our molarity, or the strength of the acid. We haven't a clue, we don't know, that's what we're trying to find out. And we have the strength of our base given to us in the question. The only two things to fill in then are these Na and Nb, or the number of moles of the acid and the number of moles of the base. Now this isn't concentration, this is the ratio within which hydrochloric acid and the Na2CO3 react. If we look here, 2 moles of hydrochloric acid react with 1 mole of sodium carbonate. There's a 1 there. So our ratio of hydrochloric acid to sodium carbonate is a 2:1 ratio. And that's what the number of moles is about here. So you fill in your 2 and your 1 here, and that gives us all the bits of information then. So the key thing here on this is now we have 6 pieces of information, we know 5 of them, okay, which is what we want. So then with all these titration questions then, this is our formula for filling into. So this is always going to look like, if I can just put a box around this. So there you go. That formula is what we'll always be filling into for any titration question that we're going to be doing. All right. So it's going to be the volume of the acid by the molarity of the acid over the number of moles of the acid equal to the volume of the base by the molarity of the base, or the concentration of the base, or the strength of it, over the number of moles of the base. That's what's always going to be done here, right? So let's fill in. So here, the volume of my acid is 22.6. The concentration or the strength of the molarity of it is X, and the number of moles is 2. Same the far side, the molarity of the base, the volume of the base is 25. The molarity is 0.05, and the number of moles is 1. Okay, at this point then, in order to try and get, or we're trying to isolate this X, the whole thing is to get this X on its own. So we want to get rid of our fraction, so the handiest way is to cross multiply. So the top on one side by the bottom on the other, and vice versa. So that's going to give us, let me know, it's going to give us 22.6 times X times 1. In other words, these two guys by this guy here, equal to the bottom on this side, so 2 times 25 by 0.05. In other words, the 2 here by the 25 and 0.05 on the top on this side. Okay, so now that's going to give me 22.6 times X. The 1 there, we'll just get rid of the 1s because this is going to keep it the same, equals to 2 times 25 times 0.05. Now, as we said, the whole purpose of this is to try and isolate the X. So in order to isolate the X, we look at what's causing the X not to be on its own, which obviously in this case is 22.6. So to get rid of the 22.6, we divide across by 22.6, and that will cause that to cancel, leave me with just an X down here. However, because this whole thing is an equation, I need to also divide the right hand side by 22.6 as well. Okay, and for me to calculate X then, it's just a matter of working that out. If you type it into your calculator, you'll get 0.110619,469. Now, that's moles, that's the concentration, and all we can do then is just round it off to go to 0.11 moles per litre. So that is the strength of our acid. Now, just double check that the acid or anything else in that. No, so just calculate a moles per litre, the concentration of the hydrochloric acid, and that's it done. Okay, so that is that question. I'll just scroll down there so you can see it in the video. You can pause or whatever else it is. Done. And that's the mathematical part of the first question. Now, I do have, if I can find it here, here is the questions you got, right? So this is question 2 here, right? And again, part F, now you have this as a copy, right? You'll find it on Schoology. Part F here again, this is the bit I want you to do tonight, okay? So you're asked to find the concentrated hydrochloric acid again, but your different volumes. Now watch, it's a slightly different question. And the actual mathematical part of it is identical. But they're giving you rough titration, first accurate titration, second accurate titration. Remember, we do not take the first rough titration. That's just to give you an indication when you're carrying out the actual titration. So when you're giving your volume of hydrochloric acid used, it will be an average of the two of them. And you know how to calculate an average, or you should do at least. Okay? So guys, what I want you to do is to carry out that tonight. I will create a little assignment tonight, literally. All I want you to do in this, it should only take you about 15 minutes, is to do that little calculation there. Is that alright? And just work it out. And what I'll do tomorrow then is we'll move on. Obviously we're not in school, so we can't do the next experiment, but I'm going to show you a video of it. So we'll look at the video and then we'll start doing some more questions based on that one. Okay guys, so as I said, I'll create a little assignment now for you with the only job you have to do is get that part F done for me. Okay, hope this has helped. Take care, bye bye.